This is Techno, a show about innovations that can change lives.
The science of fighting a wildfire.
We're going to explore the intersection of hardware and humanity, and we're doing it in a unique way. This is a show about science by scientists. Let's check out our team of hardcore nerds. Dr. Shinny Samara is a mechanical engineer. Tonight, saving baby Grace. Doctors try a cutting-edge treatment to help heal this little girl's brain, infusing her with her own umbilical cord blood.
How important is this treatment?
We hope it's gonna rescue her brain.
A mother's incredible journey to help her little girl.
The choice to save the cord blood, was that mother's intuition?
Do anything you can to help her out.
Dr. Crystal Dilworth is a molecular neuroscientist. Tonight, she introduces us to a young scientist out to change the world. And I'm Phil Torres, I'm an entomologist. That's our team, now let's do some science.
Hey guys, welcome to Techno. I'm Phil Torres, joined by Dr. Crystal Dilworth and Dr. Shinny Samara. Now, Shinny, you're about to take us on an incredible journey. This is an experimental treatment of a baby girl named Grace Matthews.
Yeah, this is a very emotional piece for me because we followed the retrieval of Grace's umbilical cord blood stem cells. And we got access to the deep freeze at Duke University, whereby they actually reconditioned those cells for treatment in the hope of saving her life. Let's take a look. It was just after 8:30 p.m. by the time Sarah Matthews, her mum, and baby Grace stepped out of their pickup truck.
Very long day. Started at 5:15 this morning and still going.
And into the North Carolina night.
Hi, Sarah Matthews. Welcome to the Ronald McDonald House. Thank you, ma'am.
This isn't the first time they've come to the Ronald McDonald House near Duke University, and it won't be the last. They're here for little Grace.
Oh, lovely seeing child reception. Hi.
Hi.
Hi, Grace. Hi.
She's fascinated by you. When did you find out that Grace had this condition?
It was the 20-week ultrasound. We went in to find out if it was a boy or a girl and found out it was a girl. Sat there and waited for the doctor to come check us. And then she came and got us, took her in her office and said she had bad news.
Grace was diagnosed with a condition called hydrocephalus, or water on the brain, characterized by the telltale swelling of the baby's head.
I know me and my husband have been married for 12 years and then figured we couldn't have children. And then all of a sudden I turned up pregnant. And that's why her name is Grace. Sorry. And then to find out she has something wrong with her. You do anything you can to help her out. I'm sorry.
If you look closely at Grace, you can make out the outlines of a shunt put in the day after she was born. It helps remove fluid from her brain gradually and directs it back into her body. The shunt should keep Grace's head from growing too large, but that's only half the battle. The swelling and all that fluid has caused damage to Grace's young brain. Now doctors hope they can reverse that damage using Grace's cord blood to regenerate brain cells. Tomorrow, this little girl will engage in the high-tech treatment that will hopefully save her brain.
So the choice to save the cord blood, was that mother's intuition?
Yes. Yes, it was. If it's something that's going to help her, we're going to do whatever we can to help her.
And had you read up on what cord blood does and how it could be applied?
No, I had no idea what it was, what it could do.
It's just after 10 a.m. in the morning, but the Matthews have been at the hospital for hours. Grace has been weighed, measured and probed. Now she's settled into a corner room in a special wing at Duke Children's Hospital.
Grace! She's a lot more peaceful now. Yes. I don't think she liked being weighed and...
No, not at all.
So now what happens?
Now we wait for, I think the nurse comes in and evaluates her in here, and then we'll wait for the cells to get thawed out.
How are you feeling at this point, Sarah?
Good, really good.
Yeah?
Yeah.
This is the day Grace receives her infusion of cord blood. She's part of an FDA study that aims to put data behind one of the most exciting areas of research, the use of cord blood to heal brain injuries.
She has a history and a physical that was done today. Everything looks good, so she's all set and ready for her infusion this afternoon.
The cord blood program at Duke University is the brainchild of Dr. Joanne Kurtzberg, who is more than just the head of the program. She inspired and created it.
Stem cell therapy has been around for a while, hasn't it? But not necessarily umbilical cord blood.
Right. So the word stem cell can be very confusing because it's used in a lot of different ways. We are working with stem cells from cord blood, which is the baby's blood left over in the afterbirth, after a baby's born, and which used to be discarded as medical waste. But about 20 years ago, it was discovered that there are blood stem cells in cord blood, and now we know that there are stem cells of many different tissues and organs in the cord blood, and that it can be frozen at the time a baby's born and used for therapy later in life.
Or for Grace Matthews now, when she needs it most. It's just before noon. Grace is ready, and now the scientists will take over and get her cord blood ready.
This is where Grace's cord blood is stored. I'm at Duke University's stem cell laboratory, and the temperatures in here are minus 300 degrees Fahrenheit. What happens from here is that technologists will take the samples out and prepare it while Grace waits in her hospital waiting room.
So this is a Thermogenesis bioarchive liquid nitrogen freezer. We store cord blood samples in here.
So are there many samples from different people here?
Yes, so this one freezer holds approximately 3,600 units.
So Grace's cord blood is being selected as we speak?
Correct.
Inside this frozen bag is the medical equivalent of gold, Grace's umbilical cord blood. It was harvested at the time of her birth and has been stored here at the stem cell lab ever since. Senior lab technician Ann Kastner will prepare it for infusion. That process is extremely precise and will take more than 90 minutes.
So you're making sure you get every single blood cell out of that bag?
Mm-hmm.
How many cells are in that bag?
In this particular bag, 253 million. Total
So you've actually
nucleated white
counted.
cells. Yes.
That's a lot of cells, it sounds like.
It's a lot, and it's sufficient because Grace is so young.
After an hour of thawing, spinning, and cell counting, it's time for the most critical phase of the procedure.
So that part is what it's all about?
Yep, the cell's right there. So we're just going to resuspend those in this liquid that's left, and we'll pull a sample out and do a cell count and see what we have.
So you were clicking every time you saw one?
Yes.
There's one. So that's a dead cell?
That's a dead cell.
The rest look perfectly healthy.
Then, 94 minutes after the process begins, Grace's blood is ready.
All yours. Appreciate it. Thank you.
So Grace's stem cells are in this box, precious cargo. And we're making our way in this van to Grace's hospital room where she's waiting for this infusion to happen. Time really is of the essence now.
We've been there all morning as Grace's team of nurses and doctors prepared for this moment.
So what happens next?
So what happens next is I'll give them a call and down in headquarters and let them know that cells have arrived, and they'll come down and get started. That's it. Exciting. Yeah, it's just a waiting game now. All right.
Now that her blood has arrived from the lab, the wait is finally over. It's now just after 2:15 p.m.
Hi. Grace, how you doing?
The team's ready. The bag containing Grace's cord blood is now in her doctor's hands. Grace suffers from hydrocephalus, where an excess of cerebral fluids squeezes and damages her brain. The condition will be with her for life, But Dr. Joanne Kurtzberg is hoping this procedure can help her regain normal cognitive ability.
So do the stem cells actually help to repair the brain damage?
So we think that the stem cells help repair the brain damage, but not because the cells directly replace cells in the brain, but because the cells give signals to what are called neural stem cells in the brain to come and repair the injury. We made her work hard.
It's okay. It's a I told you it was all over.
Okay, I'm gonna start in bed,
How long does this part take?
5 to 7 minutes. It's dripping in from here, so it just depends on the size of the vein, but it'll take about 5 minutes.
How important is this treatment for Grace?
Well, we hope very important. We hope it's gonna rescue her brain from some of the effects of the pressure from the hydrocephalus she had when she was in utero.
So there's a lot of blood that comes from the placenta, but only a tiny fraction of that is useful for your work.
You know, when we collect a cord blood, we typically get 3 to 5 ounces of blood. And in that 3 to 5 ounces of blood, there's 1 or 2 at the most billion cells. But only a small fraction of those cells are the important cells for therapy. For example, there are probably only 20 real stem cells in the whole cord blood collection. And we don't know what they look like. They're hiding out. So we know they're in there, and we know that when we give the whole unit, as we call it, back, they'll be contained in the other cells, but we don't know how to pull them out and find them and just use them alone for therapy. But besides those 20 or so stem cells, there are probably hundreds of thousands of what we call progenitor cells. And they are cells that are they've already made the decision to be one type of cell, be it a liver cell or a heart muscle cell or an islet cell or a blood cell or a lung cell or a brain cell. And when we infuse them back in the patient, they're the ones that go to damaged organs and do the real job of helping repair those organs.
Grace is not alone. Across the country in Pasadena, California, another little girl named Grace does what she loves. Swings on the swing and plays with her big sister, Mum and Dad. 6-year-old Grace Rosewood is able to do a handstand now.
Wow! Yay! Grace! Wow! Grace!
Well done, Grace.
Wow!
Gosh, I wouldn't be able to do that.
And even gives me a high five. All things she couldn't possibly do just a year ago.
We were headed in a very bad direction with what she was going to be able to do in her life, and I really felt like she was in a prison of her body. I could look in her eyes and see her consciousness, but I felt like she was trapped, and I could tell she was frustrated because she was trapped.
Happy birthday, Grace!
Grace was also infused with her cord blood at Duke Children's Hospital. Her treatments ended in June 2013.
And how do you feel today after 3 treatments?
It's been the miracle of our lives, you know, the most wonderful thing that could have happened for our family and also for Grace. For Ava, she just desperately wanted to play with her sister and connect with her somehow.
You can lean against the wall.
I actually, yeah.
There's a tie that'll tie around the back of your head. But there's a little loop you can put them on. They don't need to.
If the future of cord blood technology is being written, it's being written in a lab Duke calls the GMP lab. Getting in isn't so easy. It requires a bit of wardrobe change. Sterility is essential.
So what actually happens in here?
And this is where we manufacture the cells we're making from cord blood to use for treatment.
Just so I understand, you've identified cells that are really useful, so you're trying to recreate those particular ones.
Right.
And you're recreating those particular ones because you know that they can treat certain brain diseases.
Correct.
Okay.
And we've taken these cells and put them in animals with certain problems in the brain and shown that they correct those problems.
So with the case of Grace, she's had several treatments now, but part of the cord blood was saved. From that, are you able to recreate more of the cells she needs?
Well, if, for example, these are the kind of cells she needs, we're now at the point where we can recreate these cells. And if she needs a different kind of cell, then we have to learn how to create a different kind of cell. But we're focusing on the brain, so this would be the right kind of cell for her treatment. And we've recommended to all our patients that we save back a little bit of the cord blood to be able to manufacture more cells that could be effective for their treatment.
Back in the hospital, Grace's long day is just about over.
Good. All right, she did it.
Yay!
Sorry. Okay.
So are you happy with how today went?
Yes, today went great. She did well.
Thank you so much.
You're welcome.
Anything else we can do for you?
I'm good. All right. All right. Well, you're good to go. Okay. If you need anything, I will see you in a couple.
Thank you.
All right. Bye.
Long day.
Very.
You must be ready for
Ready to go? Yeah.
just rest.
Yes, go to sleep.
Grace is definitely ready. How personally rewarding is stem cell technology for you?
For me, it is rewarding because I've seen it help people, which is the most rewarding thing I think a physician can do. But also because I think it has enormous potential to do a lot more than we can do today. And I personally believe that cell therapy and regenerative medicine is going to be the next big advance in medicine, and that cells like cord blood are going to drive that forward.
You know, I was so moved by doing this story, and not only moved, but amazed as well by the work of Dr. Kurtzberg, because this technology really has boundless potential. And one of the first things I did as soon as I finished this film was ring up my sister and make sure that she's banking her cord blood because she's expecting soon. Because it's just such, you know, incredible technology. Yeah, absolutely.
This is so exciting. Stem cells present a great and amazing potential and focus for scientific research. And the idea that you have these what you call undifferentiated cells that can become brain cells, they can become heart cells, and if we learn to interfere at different steps of that process, we can really begin to address so many medical issues.
Now, I know coming into this piece, I'd never actually heard of this use of cord blood, and I would imagine a lot of viewers had maybe never heard of it either. What would you tell expecting mothers out there about what they can do with cord blood?
I definitely want to push the message that just bank your umbilical cord blood. It's as simple as that. And, you know, some people think it's highly expensive, and there is a cost involved if you want to bank it privately, but there's also the zero-cost option to bank your cord blood publicly.
Now, what's the difference between this public and private banking?
The difference is that if you bank publicly, your stem cells are available to absolutely everybody. If you bank privately, then you can retrieve your own stem cells.
Shinny, when you said you got embedded in the field, you really meant it.
Absolutely. Here's a Twitter picture of the team. The cameraman, audio guy, and producer, all in bunny suits, they called them.
You guys are looking good. And if you want to see more images like that from the field, be sure to follow us on Twitter. Crystal, you're about to introduce us to a girl, 16 years old, and her work has the potential to save almost 1 million lives every year.
It does. Actually, Shreya Ramaya was just 13 when, inspired by a family trip to Cambodia, she learned about malaria and the global problem that this disease presents. She learned also that the treatments that we have aren't very effective, and she wants to help do better. So let's take a look.
This was my first year at the Intel ISEF. I got 4th place in the chemistry division. I also won the 3rd place American Chemical Society Award. It was a really exciting experience because I got to see that there are lots of kids that are interested in doing research just like me, and it made me feel kind of at home. I'm Shreya Ramaya, a junior at Palos Verdes Peninsula High School, and I'm 16 years old. My project that I submitted to the Intel Science Fair this year was working with different anti-malarial drugs to try to find a way to create new compounds that can be used in effective treatment of malaria. So basically, we're in this arms race against the malaria parasite. As we evolve our medical treatments to combat the disease, the parasite itself is constantly changing and mutating, and this is causing a lot of problems in the medical world. So my family has always gone on a lot of different international trips. A few years ago, we actually went on a trip to Vietnam and Cambodia. And when I was in Cambodia, I visited a village, and then I saw this child who was suffering from high fevers and chills. And when I returned, I did some more research and learned that malaria was definitely the cause of this child's suffering. And at that moment, I realized that malaria is not just a problem that affects some small portion of the population. Roughly 300 to 400 million new cases of malaria are diagnosed every year. And I figured that if we're dealing with such a large problem, there must be a solution that can be affected by somebody. And I decided that I wanted to be that somebody. Based on my experiences abroad, I was able to come up with my research idea, and with the help of Dr. Prakash and all of the students at the Loper Hydrocarbon Research Institute, I was able to come up with the research that I submitted to the science fair. It was great because I was in an environment full of people willing to help me out. I want to be able to work in a laboratory in the future because finding problems that I'm passionate about, because I know that if I work really hard, I can try to find a solution.
I think this is another really excellent example of how getting involved early in middle school and high school can contribute to some amazing advancements in science. You don't have to have a university degree to contribute. Absolutely.
I'm struck by the audacity of Shreya because malaria has boggled the minds of scientists for so long. And not just, individual scientists, but big corporations trying to find treatments. And she comes along at the age of 16 and tries to find a better cure. It's fantastic.
I think that audacity and that curiosity was really nurtured by the high school that she came out of. I mean, they have a great research program where these high school students are acting just like researchers. They have their individual projects. Their advisor is their high school science teacher, and he helps them and leads them to resources to answer their own questions instead of just standing up there and giving them the answers on the test.
Now, do you guys see a little bit of yourselves in somebody like Shreya?
I wish.
Yeah,
I really wish I was that driven at the age of 16.
I will say, here at Techno, I always love when we get to meet these brilliant young minds. We've seen inventors, chemists, young doctors, all of this. It's so cool just to see what teenagers can come up with.
And the future of science is looking really bright.
It's looking very good. Now, I think today's theme was really inspiration. The inspiration of trying to save somebody like baby Grace, the incredible devotion of Dr. Kurtzberg in her work, and a 16-year-old girl who's pushing the boundaries of science. I absolutely loved it. And if you guys want to see more just like it, be sure to tune in next time here on Techno.
Dive deep into these stories and go behind the scenes at aljazeera.com/techno. Follow our expert contributors on Twitter, Facebook, Google+, and more.